Michaela is back in Arctic Svalbard. It's hard to believe, but this frozen world is actually the fastest warming region on the planet. She's meeting Dr. Liz Thomas, a climate scientist for the British Antarctic Survey, to find out how climate change is speeding up the end of the Ice Age.
Liz, you're all packed up.
Yeah, all ready to go.
Liz is a leading expert in ice core science, drilling deep into ancient ice to find out how our addiction to fossil fuels is heating up the planet.
So when I look at the snow, I think about all the information that it actually contains, and that helps us to understand how the climate has been changing.
Until relatively recently, the Ice Age was still a real mystery, but some of the clues to the puzzle are in the ice.
Exactly, yeah. So ice core science is relatively new, and it's only really in the last kind of 50 years that we've started drilling ice cores, and that for the first time showed us how the climate has undergone these quite dramatic changes, particularly the changes in temperature from the last ice age to our present conditions.
We're taking local transport known as a belt wagon, travelling from Longyearbyen, the most northerly town on the planet, to a remote glacier where we're expecting temperatures to be as low as minus 25 degrees Celsius. We're going to drill into the glacier and hopefully remove an ice core, which we'll send back to the laboratory for analysis.
We're going to start then.
Well, do you reckon you want to have a little go at it now, Michaela?
It'd be quite nice to warm up, actually, yeah.
The British Antarctic Survey team have got a good reputation when it comes to groundbreaking scientific discoveries. It was their discovery in 1985 of the hole in the ozone layer caused by man-made aerosols that galvanised the world to ban them.
Right, should we try and pull this one up together?
Come on then.
Okay. It's going to be heavy. You can really feel the weight in that one now, can't you?
That's great.
Oh, it's there, yeah.
It is indeed.
Down here?
That's perfect.
Oh, wow,
And
look
this
at
is the ice core. This ice that we're looking at here could be anything between 1,000 to maybe 3,000 years old, and so we can actually learn an awful lot from this very small section.
The ice core will be returned to Liz's lab for testing. So what might the gases trapped inside the ice reveal about the dangers in store for our planet?
We could plummet into Ice Age-like conditions.
We're going to see huge problems for humanity. There's grim times ahead.
I've been drilling ice cores in the Arctic to find out how close we are to another great flood like the one that ended this ice age.
Oh, wow,
And
look
this
at
is the
this.
ice core.
Inside a high-tech freezer, Dr. Liz Thomas is preparing to examine those cores and discover what clues they hold.
And this is a section of ice from Antarctica that actually goes back into the last ice age. So what you can see is inside here, these are the bubbles that have been trapped as that snow fell and then became compacted. It's actually the air that the Neanderthals were breathing in.
That's very cool, or shall I say very freezing cold. OK, that really is amazing, isn't it?
It is.
In order to examine the ice core, it's cut down to 3-centimetre thick sections, melted slowly on a hot plate kept at 20 degrees Celsius, before being piped through tubes into the laboratory next door. Here, gases released from the bubbles trapped in the ice should reveal what's in store for humanity in the future.
So out of the freezer into the warmth of the lab, and this is obviously where you collect all the data, Liz.
Yes, so on the other side of this wall is the melt head. So that liquid is being drawn down through all of these tubes.
And then you collect the air bubbles as well.
Yes, so the air bubbles we can see are coming through here.
Liz analyses the concentration of methane trapped in the air bubbles. This greenhouse gas traps the sun's heat within our atmosphere. Higher levels lead to melting ice caps. By measuring the concentrations along the length of ice cores, Liz can show me how much the planet's temperature has varied over the course of the last 800,000 years.
And what we can see is there's very natural cycles between the extreme cold conditions down here, and then up there we've got these relatively warm conditions.
It's a natural cycle taking place every 100,000 years when the Earth's orbit changes and it gets closer to the sun, triggering the Great Thaw. But that natural process changes dramatically 170 years ago when greenhouse gases skyrocket.
Is that the spike in the Industrial Revolution?
Exactly. So what we're seeing here is from the 1850s, when we really started to ramp up the burning of fossil fuels and heavy industry.
Since the Industrial Revolution and the invention of the combustion engine, CO2 levels have increased by 100%. That's a phenomenal surge in just a few years. And now we're living in the hottest period for 125,000 years.
That really rams it home, doesn't it?
That's the bit that's quite alarming. We're in the unknown, so really it's trying to understand how the planet, how the climate is going to respond to these big increases.
Svalbard is on the front line of global warming. What happens here will affect all of our lives. In the last 100 years, the glacier has retreated by 7 kilometers, and by the end of this century, it's estimated that the winter temperature will be 10% warmer.